Hello students, welcome to AcadShala. Today we are going to do the part 2 of the chapter Gravitation. Now, again I would like to say that the whole chapter revolves around this formula, that is F is equal to G m1 m2 upon r square. But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all. Today we are going to do some numericals based on this topic. Now, universal law of gravitation, as you know it very well, this formula is applicable everywhere, anywhere in this universe and is a mathematical expression of universal law of gravitation. Now today we are going to find the SI unit of G, that is capital G. As we all know, the value of capital G is equal to 6.67 into 10 to power minus 11, which you should always know along with the unit m square oblique kg square. Now this portion is known as the derived unit. That means we are going to derive this unit just now in front of you. Now, as we know that F is equal to G m1 m2 upon r square. Now this is very important. Now, we also know that force is always given with Newton. Then we will write N, that is Newton, under F, which is known as force. Then we will write G, capital G. Instead of M1, you know the masses are always in kg. So what I will do, for M1 mass, I will write kg. For another M2 mass, I will write again kg. Upon r square, that is r is the distance and distance is always given in meters. So I will write it m square. After writing this, I will solve further. That will give you capital G, kg into kg, kg square as written over here and m square over here. So this way we have derived this unit. After this, we will write as final, that is capital G is equal to n m square upon kg square. So this is the derived unit which we have done, that is the SI unit of G. Now the next numerical, it says 2 masses of 1 kg each are separated by a distance of 1 meter. Find the force of gravitation between them. Now what we will do first? We will show 1 kg over here. We will put 1 kg of the 2 masses. And then we will show the distance between the two of 1 meter, which is given in the numerical over here. And these are the forces. Now, before doing any numerical, always remember children, whatever is given in the numerical, we always should write it over here first. So, M1 is equal to 1 kg, it's given already over here. Then M2 is equal to 1 kg, again it is given over here, see, over here. So, I have written it over here. And R is, that is 1 meter distance between these two. So, it is 1 meter, so I have written it over here. And then I have written that it is given in the numerical. After this, we all know what? That is F is equal to G m1 m2 upon r square. This we know it very well. That is the whole chapter revolves around this formula only. After this, we will put the value of G, which we already know it, which we should always memorize for the numerical point of view. So the value of G is 6.67 into 10 to power minus 11. So I have written it over here, the value of G. And then what is the mass of M1? That is 1. So I have written 1 over here. What is the mass of M2? That is 1. So I have written 1 over here. And what is r square? That is the distance between the two masses. That is 1 meter. So it is r square. So I have written 1 square. Now solve it. So it is very simple calculation. Everyone will get cancelled, and then I will get in the last, that is F is equal to 6.67 into 10 to the power minus 11 Newton. This way, this numerical is solved. Next, the mass of the earth is 6 into 10 to the power 24 kg and that of the moon is 7.4 into 10 to the power 22 kg. If the distance between the earth and the moon is 3.84 into 10 to the power 5 kilometer, calculate the force exerted by the earth on the moon. We will take G value over here, 6.7 into 10 to the power minus 11 N meter square kg inverse square. Now, whatever is given in the numerical, we will write it over here. That is mass of the earth, that is 6 into 10 to the power 24 kg. I have written over here. What is the mass of the moon? That is, it is 7.4 into 10 to the power 22 kg. And what is the distance? Distance is this, that is 3.84 into 10 to the power 5 kilometer. Now I need to convert kilometer into meter. So what I will do? I will multiply with 10 to the power 3. So I will get kilometer into meter and then I will solve it further. So the value comes out to be 3.84 into 10 to the power 8 meter. So this is the final, that is the distance I have calculated from kilometer to meter. Now after this, we all know it again that the chapter revolves on this formula, that is F is equal to G M1 M2 upon R square. So what I will do, I will write down the value of G which is given in the numerical as this. So I will write it 6.7 into 10 to the power minus 11. Then M1 value which I have written over here, 6 into 10 to the power 24. Then M2, this is 7.4 into 10 to the power 22 upon, what is it? That is the distance R square. This is 3, that is this over here, 3.84 into 10 to the power 8. But do not forget to write down whole square because it is square. So this is the mistake children do it. So never forget to put it as squared. After this, we will keep on calculating, solving it further, this numerical, and after solving it, we will get this value. Always keep it in mind, children, while solving the numerical. It's very, very important trick to solve it in a better way, that you take up all the tens on one side as I have taken it over here and then keep on solving, and then you get the final answer in the form of Newton, which is the requirement of this numerical, the unit Newton. Okay, after this, then the last wordings which you have to write it when you have taken out the answer. Thus, force exerted by the earth on the moon is 2.02 into 10 to the power 20 Newton. So this is the way we solve the numerical, that is step by step, taking all the tens on one side and then solving it with a very easy manner. And if in the numerical, if the value of G is given this, so please take this value only. If it is not given, then you take 6.67 into 10 to the power minus 11. Usually in the numerical, they tell us to take this value just to make the calculation very easy. Now next, what is the magnitude of the gravitational force between the earth and 1 kg object on its surface? Mass of the earth is 6 into 10 to the power 24 kg and the radius of the earth is 6.4 into 10 to the power 6 meter. Okay. Now, this is the object and this is the radius, and they said that what is it? That is, on the earth some mass is kept. Okay. Now, what I will do, I know this kg, that is the mass of this also. Now, what I will do, I have put this some object on the earth and then I have taken the radius, but we will neglect the radius of this particular object which is kept on the earth. So I have written it that this I will neglect it just to ease out the calculation. Okay, now again I know that F is equal to G M1 M2 upon R square. I will put the value of G over here, but over here no value of G is given. So I have taken 6.67 into 10 to the power minus 11
M1 is what? That is, it is given what? That is 6 into 20, 10 to power 24. And then what is it? M2, this is 1. Correct? After this, I have put up the radius value, that is 6.4. It is given over here. 6.4 into 10 to power 6. Do not forget to put it whole square because it is r square. Always remember. Now, after this, please do the calculations, simplify the calculations, simplify the numbers. Again, take all the tens on one side. And then after calculation, when it is eased out, you get the final answer, that is 9.8 Newton. So always remember, children, always ease out the calculation by putting all the tens on one side and then keep on calculating in a simplified manner. And the one most important thing, again, I'm telling you, if the G value is given in the numerical, to take it as 6.7. So please take it. If it is not given in the numerical, you take it yourself, but you need to remember the value also along with the formulae, which is very, very important for the numerical point of view. So in this way, we also solved this last numerical. So this is the way. Always remember in the numerical that always write what is given in the numerical and what you have to find out. Then again, you write down the formula, place the values, convert the values into the required values, and it means, I mean to say, about the units, and then simplify by putting all the tens on one side and then solve it in a best possible simple manner. So this is all about today, children, in this session about the numericals. Please keep on revising on the daily basis. And if you like the video, always subscribe and always share with your friends AcadShala link so that everyone is benefited out of it. With this, I wind up the session. Thank you, children. Bye-bye. God bless.